Hello, my name is Amina Dasuki. This is chapter 3, the presentation for chapter 3, and that's derivatives and applications. Under this topic, I've chosen velocity. Why I chose velocity is because I wanted to study much about how we use differentiation to determine velocity. A typical example of velocity in our everyday life is as a vehicle is moving along a straight section or a road, its velocity is change in displacement per change in time, while in the exact same sides of differentiation. So in terms of differentiation, velocity is the rate of change of distance for displacement with respect to time. So a summary of what I'm going to be teaching is given a displacement or distance equation to produce arrive at your velocity at a particular time. Firstly, we will differentiate the displacement function, put the time given into the velocity equation. You will then arrive at the velocity demanded. And do not forget that the units for this displacement equation is meters per second. I expect the observer to be able to calculate or differentiate a distance between a distance function to arrive at the velocity function. Secondly, I expect the observer to be able to calculate velocity of a given time period. I don't think we need even a distance equation of st is equals to 12t squared minus 2t cubed, where t is greater than or equals to 0. Determine the velocity at t is equals to 4. So these are the key things that you need. First, as stated, differentiate. So this ds of t over dt is equals to 24t minus 6t squared, and that's because we've differentiated. So 12 times 2 is 24, and then this gets minus 1, so that's just 1, and then 3 times 6 is 3 times 2 is 6, and minus 1, that's 2. Next we put t into equation, and as t equals 4, so your answer will be dst over dt equals to 24 multiplied by 4 seconds, so this is 4 seconds, minus 6 by 4 seconds squared. So this will be, your answer will equal to 24 times 4 is 96. 96 seconds minus 6 times 4 squared times 6 is also 96 seconds. So your answer will equals to 0. So 96 minus 96 is 0 meters per second. Hence, from the example at t equals 4, velocity is equals to 0. This means that the Cartesian plane at t equals 4 seconds, the velocity function on the graph, cut the x-axis at 4, 0. So these are your coordinates. One other meaning for this, like these points, is that when t is equals to 4, the object is stationary or at rest. So that's the end of this presentation.